Welcome to the lecture. So in this video lecture, we are continuing the topic, that is the topic of simple linear regression. In short, we will also call it as the SLR. So let's get started. So this is the flow diagram of the SLR, that is the simple linear regression. So the first step is to explore the data, and the second step is to derive and analyze the descriptive statistics. So in these two steps, what you have to do? You have to see that what type of data is present in your data set. So you have to explore your data, that what type of data is there in your data set and in which type of data you are interested for. So the feature selection part and what type of data is present. So that is the part of the explore the data. Then we have to perform the descriptive statistics on the data. So you have to find over here that what is the mean, what is the median, what is the standard deviation of the data. So you have to analyze the data in this particular two steps, that is the explore the data and derive and analyze the descriptive statistics. The third one is the pre-process the data. Suppose there are some missing values in your data, then you have to remove that missing value and you have to treat that missing value. And if the missing value is not present in your data, then just you can move forward from this step. So the fourth step is define the functional form of the relationship. Over here, you have to identify that from which two columns, or we can say the column as the variables also. So from which two variables you have a linear relationship between them. So you have to identify that from that two variables, one will be your x and one will be your y. Next is estimate the regression parameters. Over here, we will be using the OLS method, that is the ordinary least square method of the simple linear regression to estimate the regression parameters. Then we have to perform the diagnostic test. So whatever model we have built using the OLS, so we have to test how accurate the model is. So we will perform some testing criteria. If the model satisfies the test, then we have to stop our coding. If the model does not satisfy the test, then it might be possible that you have not chosen the correct two columns, the column as x and the column as y. So you have to again identify that which two column has a linear relationship between them. So again you have to repeat all this step if your model does not satisfy the diagnostic test. So there are various type of regression models. We have seen already the positive relationship, that relationship is not linear, negative and the no relationship. But we are interested for only the first one, that is the positive linear relationship. So that is what is called the SLR, that is the simple linear regression. So we have to find such type of pattern in the data plots and we have to draw a such type of line with some intercept and with some slope. We are not considering these three criteria for now because we are interested for the SLR and we have to just consider the first criteria, that is this first one. Now the question is, why to train a model? So let's take an example. The mind of the kid is not trained. The kid mind does not know about the real world objects. So when a kid looks at an object, then he does not know that what it is. So we have to teach them that what it is, what type of object is. So we have to teach them like this, that is, it has wings, it circulates air in rooms and buildings. So we call it as the fan. So this is how the mind of the kid is trained. So in future, whenever such type of object comes in front of their eyes, then he can easily recognize that it is a fan. Now let's test it on some different type of object. So this object is somewhat different than the previous one. The previous one was the ceiling fan. This is a table fan. So let's see that how this kid is identifying this is as a fan or not. So whether this kid is telling this as a fan or he is telling some another object as this is a table fan. So suppose we are asking a kid that what is this? Then the kid mind will think it has wings, it is rotating, and it is providing the air circulation in the room. So the kid will identify this as a fan. So he will tell that it is a fan. So now let's back to the data science. Now suppose we call this kid as the model. We call the data input that we have provided previously, we call it as the train data. So we will provide the train data as an input to the model. So the model gets trained based on the data that we have provided to the model. So now the model is trained. Now this model is able to predict the values. So suppose this is my test data. So whatever the values or objects are there in the test data, now the model is capable to predict the values which is present in the test data. So how the data science is working, the machine learning algorithm is working, the machine learning model is working. So we have to provide the input to the model. That input we will call it as the train data. After the model is trained, we will test the model, that whatever the model we have prepared, then how accurate the model is. The model is 100% accurate or the model is 80% accurate. So suppose in front of a model, I am providing 100 different objects. Then from the 100 different objects, the model is able to predict 80 different objects correctly and the 20 objects incorrectly. So I will call that the accuracy of the model is 80%. So now let's understand with our example. In the previous lecture, we have seen the example of the car data set with the CO2 emissions. So let's get back to it. So this is my fuel consumption CO2.csv file. I will divide the whole complete data set into two parts. I will call the first part as the train data set, the second part as the test data set. So your train data set can be of 70% or 80%, and accordingly your test data set will be 30% and 20% correspondingly. So in the train data set, your columns will be like this, that is the engine size, cylinders, fuel consumption comms, and so many columns are there, and the last one is the CO2 emissions. Whether in the test data set, you have the same number of columns, but one column will be added, that will be your predicted CO2 emissions column. So let's see this data set. So this is my fuel consumption CO2.csv file. So it contains the various different columns like what is the model year, what is the vehicle class, what is the engine size, then what is the cylinders used, and at last I have a column that is the CO2 emissions. When you select one particular row into the Excel, then it shows the count below, that is 1068. It means what? There are 1068 rows into this particular file. So for building a model, that is the machine learning model, you have to give input in such a way that there should be a minimum 700 to 1000 rows. So the model gets trained very easily if more rows are present. You can't train a model with 3 to 4 rows. You have to provide the minimum rows like this. The maximum rows in the data set can be 30,000, 50,000, 2 lakhs, 5 lakhs, and accordingly. So how big the data is? Accordingly, the model will get trained. The big the data set is, the accuracy of the model will increase. So for better accuracy, we need a better data set with more number of columns. Now let's see. I want to divide this complete data set into two parts, that is the train data set and the test data set. So I want to do splitting as 80% and 20%. So 80%, the more number of percentage will be my train data set and the less number of percentage will be my test data set. So I want to split this data set. My total number of row is 1068, where my one row indicates the column header. So I'm not considering the column header. So my total number of row is 1067. I'm taking the 80% of it. So I'm multiplying it like this, and I'm getting the answer as 853 rows. So I will do like this. That is, I'm selecting the 853 rows. So let's select it. Okay, fine. So this is my 853 rows is over here. So this selected portion will become my train data set, and this unselected portion, that is the portion with white background, will become my test data set. So the selected portion I will use to give an input to a model, and I will train a model. After training a model, I will predict the value of CO2 emissions for the test data set. So this is how the train and test splitting is done. So over here in my test data set, I have another column, that is one additional column, that is my predicted CO2 emissions. Already I am having the CO2 emissions, and one column is added over here for the test data set. So let's see this table in detail. So this is my fuel consumption CO2 underscore test. So this is my test split. I have different columns and I have the values in the different columns. This is CO2 emissions. This will become my dependent variable Y. So I'm focusing on this. I want to predict the value of CO2 emissions. So this is my dependent variable Y. So this value is already present in your data set. So when you look at the data set, so when I'm splitting this train and test, then the CO2 emission column is already present in the test data set. It is already present in the train also, and it is present in the test also. So same number of columns are present in train and test. But we will be adding over here one new additional column, that is my predicted CO2 emissions. So where this values comes from? This values comes from the prediction from the model. So these are the actual values. These are the values which is predicted by the model. So what is the difference between these two values, that is the actual value and the predicted value by the model? So the difference is 2. So whatever this difference is, that will be my error. If actual value is 96 and I am getting from prediction, that is by model, I am getting the value is 96, then the difference will be 0. Then I will say that my model is 100% accurate. But over here, when you see the different result, then there are some differences in the values. So what is this? This is my error difference. So how accurate the model is? So for that, you have to minimize such type of error. So for calculating the error, we will not be using this error difference. We will be using the concept of root mean square error. Now, the Python code for the train and test split. So we are not doing train and test split manually. We will be doing it by using the Python. So for that, we will be using this sklearn model library. So from that, we are importing this one, that is the train test split. So we have to write like this, that is the train test split. We have to provide the x and y as an argument. I want the train size as 80%, so I'm writing 0.8, and I want test size as 20%, so I'm writing 0.2. It will randomly take the different values. Over here, I have selected the first 853 rows as my training data and the last rows as my test data. But what this Python code will do, it will randomly take 853 rows. So it is not like that first 853 rows. Suppose it is taking one row from this, one row from here, and third row from here. So it will take randomly to build the train and the test data set. So you will get the 4 split like this: X train, X test, Y train, and the Y test. Because in our model we have the equation, that is y equals to mx plus c. So for the X we have train and test, for the Y we have train and test. In our implementation of the SLR, we will be using the scatter plot. What is the scatter plot? So suppose I am having the engine size as 2 and I am having the value of CO2 emissions as 200, then my blue point will be plotted somewhere over here. So if I am taking the example of this particular downward side blue point, then it is showing that the engine size is 2 and the CO2 emission is just about the 100. Suppose I am taking the CO2 emissions is suppose 120. So accordingly, this scatter plot is plotted like this. So how many rows are there in your data set? Suppose in your data set you are having 1067 rows. So 1067 blue points will be plotted in your scatter plot. Now for building the simple linear regression, we will be using the states model library. So it is in library. For training model, we will be using the fit function, that is my dot fit over here. Now I am having the equation like this of my regression line, that is y equals to mx plus c. So I have some constant in my line, so I have to add constant to the x variable. So I am adding the constant by using the add constant as the function. This function, it is the part of the states model. So I am mentioning the states model as sm. So this sm comes from here, that is my states model library. For training the model, I will be using the ordinary least square method. I have told previously that for estimation of the parameters, we will be using ordinary least square method for the simple linear regression. So it is the part of the states model. So I am writing sm.ols. I will be providing the y-train dataset and my x-train dataset. So you have to remember this, that my dot fit function is used for the train set. And for my test set, I will be using dot predict function. For performing the diagnostic test, we will be using the mean squared error and the R2 score. So again, what is this? This is the library. So sklearn library is used for this purpose. So total libraries used for the implementation of SLR. So these are the total libraries: matplot for plotting the graph, numpy pandas, sklearn states model, and the sklearn matrices for the R2 score and mean square. This sklearn is for the train test split. In the next video, we will continue this topic and we will see the implementation of SLR. So, thank you all.